So like Michael said, my name is Brooke Tornifoglio. I am an assistant professor in biomedical engineering based within mechanical manufacturing and biomedical engineering here at Trinity. I joined at the end of the summer in 2023. In my research group, we're really focusing, I can see a few of them here, we're focusing on biomechanics, biomedical imaging, and device design. And really what we're interested in is the interplay of these three separate things. So essentially, if we look at clinical imaging, what information can we get from that that informs our knowledge of the tissue, both in structure, but also what's around the tissue, what's the environment of that? And essentially, how can we figure out the form and function of different tissues and use that information to understand how devices will integrate, how to better design devices, and ultimately try to innovate within different healthcare regions. So just as an example of some of the projects we have going on, we have an Enterprise Ireland commercialization fund at the moment. And this is a 2-year project where we're focused on ventilator-associated pneumonia. So this is VAP. This is a very large clinical problem. Essentially, if you look to the ICU, patients in the ICU have an endotracheal tube which is placed and that is hooked up to a ventilator. Within that endotracheal tube, from the second that is implanted within the patient, you have this formation of a biofilm forming on the inside of that tube. Unfortunately, 1 in 4 patients in the ICU are going to develop ventilator-associated pneumonia, and worse than that, 40% of these patients are going to die. So this is a project where we're actually looking to develop a device to prevent and eliminate that risk factor for ventilator-associated pneumonia. We also have a project working with Stryker Neurovascular in Cork. For this project specifically, we're looking at tissue-device interactions. So this is looking at different thrombectomy devices in particular, looking at device geometries, looking at kind of inputs from the clinician side, so different forces, different movements of these devices, and looking at how those interactions with the tissue will ultimately impact the tissue's functionality down the line if it is impacting it. And then the last project is we have a large interest in women's health. This is an area we're actively looking to expand. So we have some students looking at breast cancer research, specifically looking at novel biomarkers for breast cancer risk stratification, as well as disease progression, and ultimately using different clinical imaging techniques to do this. So this project is very involved with different clinicians in St. James's Hospital, as well as the Mater Clinic, so that we're really keeping that clinical need very at the focus of the project, both in terms of risk stratification, as well as developing better diagnostic tools. So I recognize those are 3 very different projects, but hopefully it's clear that through those projects, we're kind of taking those ideas of device development, clinically relevant imaging, and biomechanics, and trying to integrate those and see how we could better innovate, both diagnostic tools, but also different medical devices. So thank you.